We're starting. So basically, I'm just using my webcam to catch what we're doing. All right. So we have a couple of questions here that we need to answer. The first that we're going to look at, I mean, in this tutorial, we're going to be looking at just the mathematical background that we need to take us through the course. So, of course, we hope that all of that is right behind us, but revision is always good. So, we're asked to solve an expression or to simplify this expression for 0 to n. Now, if we're simplifying that, any ideas what the first step would be? Well, recognize that we have some series. What types of series? There's some part, there's a AP in there, and there's a GP in there. But to actually work it through, we want to break them up so we can deal with them on their own. So we can actually simplify it as summation k equals 0 to n up to the 2k plus right? Okay, from there, simple, isn't it? Because almost all match the formula that we have met before. Remember the AP and GP formula, right? Can we just remember what the AP formula is? We just write down on this side.
You waiting up for people?
Yeah. Alright, since we don't have much time, put
Right.
that on top of the head.
The next term, we'll function what goes previous term.
Now, first of all, you need to know how to recognize an AP from a GP. You have these two terms and they're different. Let me put on a GP term so that it's much clearer. We move on to equal 1. This will be R. I'm purposely using R as my variable that's changing instead of K because K is in the question and I want you to think a little bit more open-minded rather than just thinking that the variables have special meanings.
ARI.
Well, if I'm using AR to the power of I, in that case, I would be the thing that is changing. So I would be my variable. You want me to do it like that?
No, but using N, right? No, using R.
I'm making N the limit. We use R in this one here.
Okay.
I can say A to the R. Or to make it match what's in your book more, let me say I can use A to the R. Doesn't matter. Something multiplying this will still be a multiplier. It won't affect the series. Now, normal limits. If in some books you may see the limit written as from r equals 0 to n minus 1, and some you may see it written as from r equals 0 to n. The difference would be the answer, because you end up something like n plus 1. Sorry. You would say something like that, a to the n minus 1 upon a minus 1. If the upper limit was equal to n, then this would have been n plus 1. In the book, I think you may have seen AR to the I. Here, the variable A is standing in for the variable R is doing in that book. Alright, so now that we have that total, we can move forward in simplifying this. So we have the limit from, this is a GP, that's an AP. How do you recognize the AP different from the GP? Well, it all boils down to where the variable is. In the AP, the variable is in a constant multiplier. A multiplier to the constant. That way, on each term, then you're appearing to add a constant amount. That's what the AP is. For a GP, you're multiplying by some number. So the variable will be an exponent in a GP. Okay, so now that we've recognized the difference, we know we can use GP rule here, AP rule here. We'll figure out what that is later. Actually, some of the common sense drops in to actually make that work. Now, if we drop in the formula, what ends up there?
You said n plus 1, so it'll be 2n.
It will be 2n plus 1.
2n goes, no, 2n. N goes, okay. So it's like 2. Mama said using a formula. Then she was confusing the K.
Right.
Saying to look at the formula.
I know.
Yeah.
Plus.
We're using the AP formula.
Oh, stick a pin. You might notice that most books would have the AP formula starting from the first term, from variable equal 1 going up to the upper limit, where the GP formula starts from variable equal 0 going to the upper limit. It's not a mistake, because we could actually have put the 0th term here, but it would have made a difference, because the 0th term would have been 0. But I multiplied this thing by 0. So the formula still stands. So from here you have n plus 1. And what does that work out to? Let's look at the last one. N squared. Oh, nobody says n squared. Did anybody say n squared? You're saying n squared to this one here? You weren't?
I was just working what was in the bracket. But,
Nah, man, save that till later. Let's just understand what this is all about. Because everything there is simple. That's what could be interesting. thing that's a GP, it doesn't have n in the exponent. It doesn't have any k in the exponent. It doesn't have a variable in the exponent. In fact, it doesn't have any variable in the summation at all. Because this is a variable. K is a variable. K moves from 0 to n. And each time you're going to be adding what? N. So the n of that, you have how much? You have n plus 1 n's. This is really n times n plus 1. And let's add those together.